Alright, this is the intermediate 4 lesson, exponents, squares, cubes, and roots, and you're going to have a lot of writing to do. So exponents. Exponents is a shorthand for multiplying the same number times itself. So for example, 4 times 4 times 4 times 4, let's throw another one in there, times 4 is 4 to the 5th. The big 4 here is called the base. The tiny 5, which is superscript, is the exponent. Once again, it's a shorthand for multiplying the same number by itself. Should also be mentioned that if you have a number like 5, it is implied that the exponent is a 1, because this is one of those 5s. If you have a variable like x, it's implied that the exponent is a 1. Squares. Squares is what it sounds like. It is a square. So if you have something like 3 squared, it means you have a square that's 3 by 3. If you have a square that's 4 by 4, that is 4 squared. How many squares are inside there? Well, there's 16. 4 squared is 16. 4 times 4. Cubes, also what it sounds like. It's a rectangular prism in which each dimension is the same length. So if each of these dimensions are 1, this is 1 cubed, which is 1. There's 1 cube inside there. If each of these dimensions were 8, that's 8 cubed, which is a huge number. Put that in my calculator. It's 512. Probably should know that. I don't. That means if this is 8 by 8 by 8, that across the bottom here we could fit 8 cubes. All the way across the bottom we could fit 64. It's 8 times 8. And then we can stack them 8 high. That would give us 512. Properties of integer exponents. So there's a lot of information that's involved in this. Let me tell you what these properties are. One property is that if you multiply two numbers with the same base, figure out what the answer to that is, you add the exponents. Example with numbers, well, with the kind of numbers, let's say that we had x to the 5th times x squared. That would be the same as x to the 7th. Add the exponents. Second property, and these properties are in no special order, if you have a base raised to an exponent, which in turn is raised to an exponent, you multiply those exponents. Example, let's say that we have 3 squared to the 5th. That's going to be 3 to the 10th, because 2 times 5 is 10. If you have a product, two things you're multiplying, and that is raised to an exponent, that means you can simply use that exponent for each of the factors that you're multiplying together. So if we had something like 2 times x to the 4th, that would be 2 to the 4th times x to the 4th. Fourth one is the quotient property. Quotient means divide. If you're dividing two things and that's raised to an exponent, you can apply the exponent to both the numerator and denominator. Example, if we have 3 halves to the 5th, that's going to be 3 to the 5th over 2 to the 5th. Finally, any number raised to the 0 power is 1, as long as that any number isn't 0. 0 to the 0 power is undefined. Any other number to the 0 power is going to be a 1. All right, let's look at an example. If x and y are real numbers, which one of the following is equivalent to x to the fourth x cubed minus x to the fourth x cubed? So I'm just going to write this down. X to the fourth times x cubed, that is the product property, which says you add the exponents, that's x to the seventh. X to the fourth cubed, that's a power to a power, you multiply the exponents, that's x to the 12th. Now, can we combine these two terms together? You can only combine them when they are like terms. These are not like terms. To be like terms, you need the same base, which they do have the same base. You need the same exponent. They are different exponents. So this is as simple as this can get. It is x to the 7th minus x to the 12th. Just to remind you what like terms is, if this was 7x minus 12x, you can combine those because they have the same base of an x and the same exponent as a 1. This would be negative 5x. Another example. Actually, no, let's talk about roots. Excuse me, I'm going to sneeze. Oh, forgive me. A root means trying to figure out what number times itself gives you an answer to something. So for example, let's say we wanted to find the square root of 81. If there's no number written in this little spot here, it means there's a 2. So square root of 81 means the same thing as square root of 81. What number times itself is 81? Well, the answer is 9. You could do, what's the square root of 4? That's 2. What's the square root of 25? That's 5. In addition to square roots, you can have other types of roots. You can have cubed root. What number times itself 3 times is 27? That's what that question is asking. The answer is 3. 3 times 3 is 9, times 3 more is 27. What's the cubed root of 125? So what number times itself again is 125, and the answer is 5. You can have all different kinds of roots. Mainly on the ACT, it's going to be square roots. Sometimes it's going to be cubed root. So just to remind you that radical and root means the same thing. Here's some roots that you should memorize. Not for the ACT, but just to be a human being alive on planet Earth. Square root of 1, square root of 4, square root of 9, square root of 16, square root of 5, pardon me, square root of 25, square root of 36, square root of 49, square root of 64, square root of 81, square root of 100, square root of 121, square root of 144. You should know all those by memory. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Write those down and memorize those as soon as possible. Okay, example, what is the cubed root of 8? What number times itself again, gives you 8? The answer is 2. 2 times 2 is 4, times 2 is 8. Number 2, I don't have the square root of 468 memorized. It's possible that this is not an integer, that it's a decimal. If you look at the answers, there are no decimals. So that means we need to break this down into its prime factors and figure out what this is. So we make a factor shrub, factor bush, if you will. 468 breaks down to 4 times 117. 4 breaks down to 2 times 2. 117 breaks down to 9 and 13. Two's prime, 2's prime, 9 breaks down to 3 times 3, and 13 is prime. Once you have all prime numbers, and you're trying to figure out what this simplifies to, you circle pairs of the same number. The reason it's pairs, this is a square root. If this was asking for a fourth root, you would need a group of 4 of the same number. So we have a pair of 2's, we have a pair of 3's. For every pair, you put one number on the outside of the radical. So we have a 2 and we have a 3. Anything that is uncircled stays on the inside of the radical. That's 13. 2 times 3 is 6. So when you get to the end, any numbers that you have on the outside, you multiply together. Any numbers left on the inside, you multiply together. So you end up with 6 square roots of 13, which is this right here. A quicker way to do this problem, much quicker, is to type into your calculator square root of 468. Hit enter. It's going to give you a number. It's going to give you 21.6 approximately. Then take all these other numbers and put them in your calculator. This is obviously not 21.6. This one here is close. Square root of 13 is less than 13. So you're really only down to 3 choices, but 6 square root of 13 will check out and give you the same answer.